Hello everyone! Welcome to Class 9 Science videos of Chapter 8 Motion. In the previous video, we have learned that a reference point is necessary to describe the motion of an object. In this video, we are going to study the simplest type of motion, that is, motion along a straight line. Consider the motion of this blue car along a straight path. The car starts its journey from O, which is treated as the origin. Let A, B, and C represent the position of the car at different instances of time. Points A, B, and C are 60, 35, and 25 kilometers away respectively from the origin. Initially, the car moves through C and B and reaches A. Then, it moves back along the same path and stops at C, crossing B. Do you know the total distance traveled by car in the entire motion? Yes, it is OA plus AC. That is equal to 60 kilometers plus 35 kilometers equals 95 kilometers. You already learned in your previous classes that distance is the total path length covered by an object. In this situation, distance traveled by car is 95 kilometers. Here, 95 is the magnitude of distance traveled by car and kilometer is the unit of distance covered. The numerical value of a physical quantity is known as its magnitude. Now, let us have a look at some other situations. Here we can see two more cars moving along the same path. The red car moved 50 kilometers forward and 45 kilometers backward, and the yellow car moved 90 kilometers forward and 5 kilometers backward. In all three situations, the distance covered is 95 kilometers. Now, look at the final position of the cars. Did they all stop at the same final position? Not exactly. The final position is different for the cars, and they are at different positions from the origin, even though they covered the same distance of 95 kilometers. Hence, to specify how far an object is from its origin, we can't rely on the magnitude of distance. To specify the change in position of an object from the origin, we use a new physical quantity known as displacement. Thus, displacement can be defined as the shortest distance measured from the initial to the final position of an object. Now, can you find the displacement in each situation? In the first situation, the blue car moved 60 kilometers in the forward direction. Then, it moved 35 kilometers backward. Thus, the car is 25 kilometers away from the origin. Here, we can see that the car has a displacement of 25 kilometers. Similarly, displacement of the red car is 5 kilometers and the displacement of the yellow car is 85 kilometers. Here, 3 cars cover the same distance of 95 kilometers but have different displacement from the origin. If we draw a circle of radius 25 kilometers, keeping the origin as the center, every car parked on the points making the circle will have the same displacement. But even though the displacements are the same, the final positions are different for these cars. From this situation, it is clear that we can't rely only on the numerical value of the displacement to locate the final position of an object. To describe displacement, we need to specify the magnitude as well as the direction of motion. Here we can say that the blue car is 25 kilometers east of the origin and the white car is 25 kilometers north of the origin. The physical quantities which are described by specifying their magnitude and direction are called vectors. Therefore, displacement is a vector quantity. But to describe distance, we need to specify only the numerical value and not the direction of motion. The physical quantities which are described by specifying only their magnitude are called scalars. Therefore, distance is a scalar quantity. Hope you all understood the concepts of distance and displacement. So, from this video, we can conclude that distance is the total path length covered by an object. Displacement can be defined as the shortest distance measured from the initial to the final position of an object. The physical quantities which are described by specifying their magnitude and direction are called vectors. Physical quantities which are described by specifying only their magnitude are called scalars.